A clear blue sky with fluffy white clouds flowing in all directions may sometimes create the most beautiful scene. When it's sunny outside and we're having a picnic, we sit back on the fragrant grass and simply gaze up at the gorgeous clouds, wondering if we've ever seen anything like it. Why are the clouds white might be a better question to contemplate. Why do the clouds appear gray at times? Are there many kinds of clouds? Well, join us as we dive into full details of the reasons behind all of this, and make sure to watch the video till the end to not miss any more information. Let's start by talking about what clouds are and how they are created in the first place. In the Earth's atmosphere, clouds are visible collections of minute water droplets or ice crystals. The size, form, and color of clouds vary widely. They can appear big and lumpy or delicate and airy, because the small water droplets inside of clouds are closely packed. When air is saturated or filled with water vapor, clouds form. Lowering an air mass's temperature is like squeezing a sponge because warm air can hold more water vapor than cold air. That squeeze of cooler, moist air has a visible impact in the form of clouds. With merely a modest cooling, moist air gets hazy. The tiny water or ice particles that make up the cloud can expand as they cool more, becoming larger particles that eventually fall to Earth as precipitation. What gives clouds their white color? There are numerous wavelengths of visible light that each have a little distinct hue and are directed toward us. White light results from the combination of all wavelengths. Although there may be a mix of wavelengths in white light, this mix is not constant. Wavelengths can be sorted out in some situations. As an illustration, blue light is typically scattered by the Earth's atmosphere, whereas the other light wavelengths pass through in a straight path. As a result, the sunlight that falls on humans is typically more golden in color because the blue wavelengths of light have been filtered out, whereas the sky appears blue. After all, it is composed to diffuse scattered light. It's referred to as Rayleigh scattering. Light is also scattered by clouds. Larger water droplets scatter all types of light in all directions, in contrast to the selective light scattering of oxygen and nitrogen molecules. My scattering is the term for this. Red, blue, yellow, orange, and green lights are all streaming toward us when we look up at the clouds. However, because all the colors are coming to our eyes from the same point, we are unable to distinguish between them. White light is created when they are all together. Because of the way that light enters our eyes, we see clouds as being white. The science behind the scattering of sunlight. A rainbow can be created by mixing all the colors found in sunlight. The wavelength, which is expressed in terms of nanometers, varies for each color. Red has the greatest wavelength at 700 nanometers, whereas blue has the shortest at 400 nanometers. While larger particles like water droplets scatter all light wavelengths about equally, smaller particles are better at diffusing short wavelengths of light than long ones. Due to the millions of water droplets in the atmosphere, sunlight is scattered into different colors, which combine to create the color white, giving clouds their white color. So why are some clouds gray? The uniform scattering of sunlight in all directions causes white clouds to form. However, when a cloud's base and sides are not adequately illuminated by light dispersion, the cloud appears gray. Large rain clouds, which have larger water droplets than regular clouds, frequently have the color gray apparent in them. Since the top of a rain cloud receives enough white light from the sun, it is still white. This is clear while looking at rain clouds via an airplane window because they appear to have a dazzling white color. Gray clouds therefore indicate insufficient sunlight reaching the cloud's base and sides. Forms of clouds. By seeing and comprehending the many varieties of clouds, one can forecast the weather since different cloud types correspond to various weather conditions. Cirrus, stratus, and cumulus are the three primary cloud classifications. Clouds in the cirrus region are wispy, curling, or stringy. They are constructed typically of ice crystals and are found in the upper atmosphere, typically higher than 6,000 meters, 20,000 feet. Cirrus clouds typically herald clear, pleasant weather. They frequently show the wind direction up in the atmosphere based on their shape. Stratus clouds have layers and are horizontal. Stratus clouds can form a single pattern that covers the entire sky. They typically take place nearby Earth. When warm, moist air is thrust up over cold air near the edge of a warm front, stratus clouds frequently occur. The cooling of the wet air along the entire front causes clouds to form. A cool, overcast day is typically predicted when stratus clouds are present. Large and bumpy clouds are called cumulus. Their name is a translation of a Latin word that means heap or pile. They can extend upward into the atmosphere up to a height of 12,000 meters, 39,000 feet, updrafts of warm, humid air that are strong enough to form cumulus clouds, and cumulus clouds are mostly responsible for heavy precipitation. Depending on their size and height, they provide different weather. The atmosphere will be drier and the weather will be fairer the higher the cloud's base is. Clouds and weather. Let's talk more about clouds and their connections with the weather. Precipitation occurs in certain kinds of clouds. Along with the lightning, clouds are also responsible for producing the accompanying thunder. Positively and negatively charged particles separate in a cloud to create an electrical field, which then causes lightning to develop. The discharge of a superheated lightning bolt to the earth occurs when the electrical field is sufficiently powerful. In reality, most lightning strikes that we mistakenly think are one are actually 3 or 4 separate ones. When the air which has been heated by the lightning bolt rapidly expands, a sonic shock wave is created, which is what causes thunder to sound. Due to the distance that thunder travels in, it might occasionally sound like waves are breaking. Since lightning usually appears before thunder can be heard, this is because lightning travels at a faster pace than sound. For many years, researchers have been experimenting with a procedure called cloud seeding. Weather patterns are to be influenced by cloud seeding. Clouds are populated with seeds or small particles. Artificial cloud condensation nuclei, CCN, which are little specks of dust, salt, or pollutants that gather in all clouds, are these seeds. Every snowflake and raindrop has a CCN. Droplets of water or ice amass around CCN. Cloud seeding is intended to give humans control over precipitation, according to scientists. So let us know what you think down in the comments section, and please give us a thumbs up by hitting that like button. Finally, don't forget to subscribe to our channel and turn on post notifications so that you don't miss any updates from us. We'll see you in the next video.